Okay. Hello everyone. We will continue the discussion about nonlinear regression. Nonlinear regression. What is nonlinear regression? The idea of the nonlinear regression is just the same as linear regression, but the difference is that my function, the approximate function, is in the form of nonlinear function. So this is a polynomial function. And what is the difference between linear or nonlinear regression? Suppose I have this as linear regression, then the function will be linear, and if I have another data and I can approximate it using nonlinear function, so maybe it will be something like this. And then the same way in linear regression that we have already discussed before, that the purpose of uh, this method is finding what is the best A and the best B, so that this function will have uh, the smallest error compared to the data. How to do that? How to find how to find the optimum A and B? First, we have to change the nonlinear function into linear function, so that we can use the formula that we have already have in linear function. How to change this formula into linear function? We can use using one of them is log function. And then this one, the function will be changed into this form. I take the log of y accent and this ax power of b, so that I have uh, this log y accent equal to b log x plus log a, something like this. And then this is linear function, as I put log in the function, and then I will have this as the gradient, and this one as the intersection of the y-axis. And I will write it down into a simple form. I rename this as p. The log y accent become p, and then b b small b become capital B, and then log x become q, and then the intersect become capital A. Then the purpose, or how to find the A and B, the optimum A and B, is by optimizing or find the minimum of the error. So what is the error? The error is e square, which is the yi, the original data, minus this approximate function pi square, like this. And you have to be careful that p is in log, this is in log, and this one still in original, is still in original. So we have to do something here. We have to change the form of the yi. So I write again square, and this is yi minus pi square, and we have to change this into log. So we have here sigma log of yi minus pi square, and I rename this I will rename this into, what do you call, w. Okay. So I will have this linear function. I'm sorry, I have this quadratic function, and I want to find what is inside in P, which has a and capital A and capital B. So now I will use the linear regression, as this is linear, as the function is linear, pi is linear. Then I will have capital B, the gradient of P, is equal to n sigma i1 until n of q I and w I, and then minus sigma qi and sigma wi divided by n sigma qi square minus sigma qi square, like this. Where as you know, pi is equal to, I'm sorry, not pi, as you know that double ui is equal to log yi and qi is log xi. Okay, then what is a is the mean of wi, I'm sorry, we thought I, so what is the a, the variable of a? It is the average of the mean of the w minus the mean of the q multiplied by b. So we have a and we have also b here. Now we put in the original form that we have p equal to capital B q plus a. This is my original function, and then we have a is equal to log a, and b is equal to log small b, I'm sorry, it should be small a, like this. And this one is b, sorry, this one is only b, so here it's small b, and because my original function is y accent is equal to a x power of b, but we have this a and this b, and we need this and this, so that using anti-lock to get a and b, so we can have this. So that's all about the nonlinear regression. Make sure that you do the assignment. Okay, thank you very